For decades, humanity has chased one dream: to build a machine that could think. Today, many people believe we've finally done it. AI can write books, generate movies, pass professional exams, write software, even hold conversations that feel almost human. But despite all of that, every one of these systems shares the same limitation. They can't pick up a glass. They can't fold your laundry. They can't repair a bridge. They can't harvest a field. They can't build a house. They can't walk into the real world and do the work that keeps civilization running. And that's why the next chapter of artificial intelligence won't happen on your screen. It will happen in the physical world. Because teaching a machine to think was only half the challenge. Teaching it to exist among us is an entirely different revolution. When ChatGPT launched, it changed the public's understanding of artificial intelligence almost overnight. For the first time, millions of people could interact with a machine that appeared to understand language, answer complex questions, and generate original ideas in seconds. Then came image generation, video generation, voice cloning, coding assistants, research agents. Almost every month, AI became capable of something that had seemed impossible only months earlier. One of 11 to many people, it felt like we had reached the finish line. But in reality, we had only solved intelligence inside a computer. Imagine explaining how to make breakfast. A language model can describe every single step. It knows what eggs are. It understands what a frying pan is. It can even explain how long to cook each side. But place that same AI inside a real kitchen, and suddenly everything changes. The pan isn't exactly where it expected. The egg slips. The handle is hot. The lighting changes. Someone walks into the room. A child drops a spoon. Now intelligence isn't just about knowing. It's about seeing, moving, balancing, adapting, reacting. The digital world is predictable. The physical world never is. And that's the challenge researchers have been trying to solve for decades. People often assume robots have existed for years. And they're right. Factories have used robotic arms since the 20th century. Warehouses already rely on automation. Self-checkout machines exist everywhere. So why is everyone suddenly talking about physical AI? Because traditional robots were never truly intelligent. They followed instructions. 2 of 11, nothing more. Imagine a factory robot whose only job is tightening one specific bolt. Every movement is measured. Every object appears in exactly the same location. Every second is carefully planned. Move that bolt just 2 centimeters, and the robot might completely fail. That's because traditional automation depends on certainty. The real world has almost none. Think about how easily a human adapts. You can walk into a room you've never seen before, find the light switch, avoid furniture, pick up a cup, open a door, and adjust your movements without consciously calculating every angle. A robot struggles with every one of those tasks. Not because it lacks motors. Because it lacks understanding. For decades, robotics and artificial intelligence evolved separately. Robotics focused on movement. Artificial intelligence focused on reasoning. One learned to move. The other learned to think. Neither could truly do both. That separation is exactly what is beginning to disappear. Today's AI models don't just recognize images. They understand relationships. They can reason through problems. They remember context. They plan multiple steps ahead. And for the first time, 3 of 11 researchers are connecting that reasoning directly to machines that can interact with the real world. Instead of programming every movement manually, robots can begin learning, observing, practicing, correcting mistakes, just as humans do. That's why experts increasingly refer to this moment as the birth of physical AI. Not because robots suddenly appeared, but because intelligence is finally leaving the screen. And once intelligence can see, move, and learn in the real world, the impact may extend far beyond smartphones and laptops. It could reshape factories, hospitals, construction sites, farms, warehouses, and eventually, our homes. The question is no longer whether machines can think. The real question is, can they work? If engineers have dreamed about intelligent robots for decades, why is the race exploding now? Because for most of history, the missing piece wasn't the robot. It was the brain. A robot can have the strongest motors, the fastest processors, and the most advanced cameras ever built. 4 of 11, but without intelligence, it's just an expensive machine following instructions. That's exactly where the industry was stuck. For years, robots could repeat tasks with incredible precision. But ask them to do something slightly different, and everything fell apart. A box placed in the wrong location. A new object they've never seen. A person unexpectedly walking into their path. Small changes that humans barely notice could completely confuse a machine. Then something changed. Large AI models didn't just become better at language. They became better at understanding patterns. Better at reasoning. Better at planning. Better at predicting what should happen next. Researchers realized something remarkable. The same kind of intelligence helping you write an email could also help a robot decide where to place its next step. The same reasoning that solves programming problems could help a machine understand how to pick up an unfamiliar object. Suddenly, AI wasn't just software anymore. It became a decision-making engine. And that's exactly what robots had been missing, but smarter AI alone wasn't enough. 4 different technologies had to mature at the same time. The first was computing power. Training modern AI requires enormous computational resources. Only in recent years have specialized AI chips become powerful enough to process massive amounts of information in real time. The second breakthrough was simulation. 5 of 11. Instead of testing robots only in the real world, companies can now train them inside highly realistic virtual environments. A robot can practice opening doors, walking across uneven ground, or stacking boxes millions of times in simulation. It can make mistakes, learn from them, and improve without ever breaking a real machine. By the time it enters the physical world, it has already lived through years of experience. The third breakthrough was sensors. Modern cameras' depth sensors, force sensors, and radar systems allow robots to perceive their surroundings with far greater detail than ever before. In some situations, they can even detect things humans cannot. And finally, the fourth breakthrough was data. Every interaction, every movement, every successful grasp, every failed attempt becomes another lesson. Just as language models learned from billions of words, physical AI is beginning to learn from billions of real-world actions. When these 4 pieces came together, the impossible started becoming practical. This isn't just another technology trend. It's one of the largest industrial races in modern history. 6 of 11 look closely at where the world's biggest technology companies are investing. Some are building humanoid robots. Others are developing autonomous factories. Some are creating software that teaches machines how to understand the physical world. Others are designing the chips that make all of it possible. They're not investing billions because robots look impressive. They're investing because the global economy depends on physical work. Every package delivered. Every warehouse stocked. Every building constructed. Every crop harvested. Every patient assisted. Every road repaired. Someone or something has to perform those tasks. For decades, software transformed office work. Physical AI could transform physical work. And the economic impact of that shift could be even larger. Think about it. There are billions of hours of physical labor performed every single day around the world. If even a small percentage of those tasks become automated, the consequences won't be limited to technology companies. They'll reshape entire industries. But before we imagine a future filled with intelligent robots, there's one important question. Can machines actually replace humans in the real world? Or are we still much farther away than the headlines suggest? Because despite all the excitement, physical AI still faces one enormous obstacle. And it may be the hardest problem artificial intelligence has ever tried to solve. Despite everything you've seen, 7 of 11, there's one problem no company has solved. The real world is messy. A chatbot lives in a predictable environment. Words follow grammar. Questions have context. Information can be processed one sentence at a time. The physical world is nothing like that. Imagine asking a robot to clean a bedroom. Simple, right? Until it sees clothes scattered across the floor. A chair partially blocking the doorway. A phone charger tangled around a table leg. A sleeping dog in the corner. A glass of water near the edge of a desk. To a human, these are ordinary situations. To a machine, they're thousands of decisions that must be made in real time. Which object should it move first? How much force should it use? Will the glass fall if the table shifts? Could the dog suddenly move? What if the room is completely different tomorrow? Humans solve these problems almost instantly because we've spent our entire lives learning how the physical world behaves. We understand gravity without thinking about it. We know fragile objects break. We instinctively adjust our grip when something starts slipping. We don't calculate every movement. We simply adapt. Teaching a machine to do the same is one of the hardest scientific challenges ever attempted. That's why, despite impressive demonstrations, today's robots are still far from matching the flexibility of an average person. Whenever people hear about intelligent robots, one question always comes first. 8 of 11, will they replace human jobs? The answer is more complicated than most headlines suggest. Physical AI isn't likely to transform every profession overnight. Instead, it will spread gradually, starting where work is repetitive, physically demanding, or dangerous. Think about warehouses. Thousands of identical boxes. Predictable layouts. Continuous movement. It's an environment where machines can deliver real value. Factories are another example. Many production lines already use automation. Smarter AI simply allows those machines to handle a wider variety of tasks with less human programming. Then there are places humans don't want to be. Deep mines. Disaster zones. Nuclear facilities. Chemical plants. The bottom of the ocean. Even distant planets. In environments like these, intelligent machines could take on risks that would otherwise endanger human lives. Healthcare may also change, but probably in a different way than people imagine. Robots are unlikely to replace doctors anytime soon. But they could assist with transporting supplies, supporting rehabilitation, helping elderly patients with routine tasks, or improving surgical precision under human supervision. Construction. Agriculture. Logistics. Infrastructure maintenance. Each industry may adopt physical AI differently. Not because humans become unnecessary. 9 of 11, but because machines become capable partners in work that was once impossible to automate. History suggests that major technologies rarely eliminate work altogether. Instead, they reshape it. Some jobs disappear. New ones emerge. The challenge is not simply whether robots can work. It's whether societies can adapt as quickly as the technology evolves. The first industrial revolution multiplied human muscle with steam. The second multiplied production with electricity. The digital revolution multiplied information with computers. Artificial intelligence multiplied knowledge. Physical AI could multiply action. That's what makes this moment different. For the first time, machines aren't just learning to process information. They're beginning to interact with the physical world in ways that once belonged only to humans. Will every prediction become reality? Probably not. Some companies will fail. Some technologies will take longer than expected. Some promises will prove overly optimistic. History has shown that every major technological revolution arrives with both breakthroughs and setbacks. But the direction is becoming increasingly clear. The question is no longer whether AI will influence the physical world. It already has. The real question is how quickly that influence expands and how society chooses to use it. Because the next decade won't simply be about building smarter software. It may be about building machines that can understand, adapt, and work alongside us in the real world. 10 of 11, and if that happens, the smartphone era may one day be remembered as only the beginning. The next revolution won't fit inside your pocket. It will walk beside you. For years, we've measured artificial intelligence by what it can say. The next generation will be measured by what it can do. The race is no longer just to build the smartest AI. It's to build intelligence that can step into the real world. And the companies that solve that challenge may define the next century of technology. If you enjoyed this deep dive, subscribe. Because behind every AI headline is a much bigger story, and that's exactly what we explore here every week. 11 of 11.